Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Gaines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we're joined by Scott Wlaschin. How you doing, Scott?
Everything's good with me, thanks. Thanks for having me on the show again.
Well, no, I was just speaking off air, saying really appreciate you taking the time again to come on the show. It was really interesting. I think it was in January, actually, the last one, to delve into, obviously your history of how you got into programming stuff and then touch upon a couple of really interesting topics in the functional realm. And yeah, I thought, it'd be great to come on again because I know you recently did another presentation at the NDC London that got recorded and has been released. I think in mid-February it got released. And yeah, I was going to say it's really, really interesting. 13 ways of looking at a turtle. Really interesting, really great title because it carries on from like some of your other interesting titles like Frankenfunctor and things like that. So always interesting titles. Because I know that it's similar to how you did your functional design patterns talk, where you took a lot of different things and you kind of condensed them down into little chunks. And actually in this one, even you had a little bell just to make sure that you got through them all. So the talk goes around, takes one problem domain and explores many different aspects, many different ways of tackling it and thinking of it. And I was just wondering, how valuable do you think, as a learning exercise, it is for a programmer to actually do this kind of, take one problem domain that they may know already inside and out and really explore other avenues?
I think it's an excellent approach, and it's especially because one of the problems when you're learning anything is sometimes you have to learn. You want to minimize the amount of new things you have to learn when you're learning something. And I know, for example, that I can't remember who it is, but there's a couple of people who, when they learn a new programming language, they take a problem that they know inside out. And I think for this person, it was writing a Lisp interpreter. But you take something that you know inside out and you've done it before, and you try and do it using the new programming language or the new functional program, new paradigm like functional programming or whatever it is. But then you don't have to worry about trying to understand the problem. You already understand the problem, and now you can really focus on the different kinds of techniques that you have to use. And I did this. This is 13 different ways of doing the same problem, which in my case is turtle graphics. And there's a woman called Krista Lopez who's done a whole book on different, taking the same problem and looking at very different ways of doing it. It's called Exercises in Programming Style. And I definitely think it's extremely useful. It's an extremely useful way of learning something because there's so many different ways of tackling a problem. It's just kind of, I think it's very interesting.
I think that what you say, is very true, that it takes away that cognitive overhead of having to understand a new problem and a new technique or something. And it really kind of it allows your brain to kind of just see the differences based on the technique and the actual solution to the problem as opposed to the actual domain itself.
Yeah, exactly.
And so your talk explores a lot of the management of state and behavior. And I really love the kind of general thread through the actual talk, of how do we actually place these and, where you place them, how they interact with each other. I'm just wondering, what was the inspiration then for this talk?
Well, it's a good question. I'm always looking, it actually came from a blog post that I did, which also was called 13 Ways of Looking at a Turtle, which actually ended up being 15 Ways of Looking at a Turtle. And, no one seems to have recognized this, but there's a well-known poem called 13 Ways of Looking at a Blackbird, which is the same kind of thing from a poetic point of view. I don't think most of my readers are particularly have a poetry background, so maybe they didn't get the joke. But so obviously, 13 Ways of Looking at a Blackbird. So it's like, well, a turtle, I can't do a blackbird, but I can certainly do a turtle, and because turtle graphics are a very well-known thing, and I thought that's a nice small domain. I mean, a lot of my blog posts, they're just, it's like, okay, I need to write something. What shall I write about? So, and I was just thinking, it's silly. I like to do silly stuff if I can, just because there's so much serious stuff, especially in the world of functional programming. And I thought something wacky. It ended up being quite a sort of serious talk, but at least the concepts, at least the inspiration was sort of strangely wacky. And in my blog post, I actually have little fragments of a poem. Which is
I noticed those.
Yeah, well, those I made up, because the real poem. But if you look at the real poem, the 13 Ways of Looking at Blackbird, I've changed the wording. So instead of where it says blackbird in the original, I say turtle, and where he has something else, mountains or something, I have monads. So it's just a very silly thing. But it's fun. I enjoy being creative that way.
I think, as you said, you took a really nice problem domain, a visual problem domain as well, I think, which worked really well in the presentation to kind of be able to see, something. I think people really do like seeing visually some things like that, and it's quite nice to build it up as being a real thing. And obviously, with using something like F# scripts and stuff, you're able to really run the code through the REPL as there and then, and you can show, this is real code that we're writing. This is a real solution I've actually made. It's not just kind of an idea in my head that this could work.
Yeah, I first of all, in my presentations and in my blog posts too, I always try and have as much graphics and diagrams as possible, because it's so much easier, I think, to understand pictures than it is to understand words, or at least it gives you the context. And then once you get the concepts, the words then make more sense. But when I'm faced with a wall of text, I find that quite intimidating. So it just helps to break it up a bit. And then, the nice thing about being able to do in the talk, I actually do live coding, or not live coding, but just a real demo, because the whole thing is just a few lines of code, which is one of the great things about F#. And so, you can actually see it work in real time. I think when I do presentations, I try to avoid having too much coding. It's kind of sometimes you go to the thing and it's just somebody typing away into a editor, and that can be a bit boring sometimes. So my stuff is sort of pre-canned, and it just means I can run it and it will work, But it's just nice to show that it's a real thing. It's not just it's not just a kind of theoretical concept. It's actually, you can actually see what the code looks like.
No, it's really cool. And I thought it'd be really interesting to go through some of these solutions. And obviously the first one that comes to mind, and this is very much, I think, familiar with a lot of people, is the object-oriented solution. And that really is the kind of idea that you'd have your internal mutable state with your internal behavior as well, and you'd just be calling the API on it, and it's really kind of treating it as a black box. And I'm just wondering, kind of like, again, people are very familiar with this approach, so that's probably one of the pros on it. But what other things do you find is a pro and con to actually this approach using object orientation for solving a problem like this?
Well, I mean, the classic thing about object-oriented stuff is it's the encapsulated philosophy that it's a black box. It keeps track of its own state. It keeps track of its own everything it needs to keep track of, and you just call methods on the object, and it deals with everything. And that's that's fine, but like I say, it's very convenient. It's very familiar. From a bigger point of view, the problem with it being stateful is, it manages its own state, but it makes it very hard to see what's going on inside the box because it's a black box. And that may be, in some sense, that may be a good thing. But nowadays, I think when we're very into doing, unit testing and so on, it's very hard to test something when you don't understand how it works inside. So the whole philosophy of making things much more transparent, passing all the dependencies in explicitly, trying to make pure functions using immutable data and stuff. Even in the object-oriented world, people are aiming in that direction because it just makes things much easier to test, and it also makes things much more decoupled because you can start gluing them. If the dependencies are explicit and the behavior is deterministic, then you can compose them together much more easily because you know exactly what you need to do to glue them together. So I think the traditional style object-oriented programming is it's actually been replaced by the agent. I mean, Alan Kay originally said that what he would call object-oriented programming would be what we would now call agent-based programming, where you have these self-contained things and you send them messages and they talk to each other through messages. And in Smalltalk, for example, that's sort of how it works in Smalltalk. The object-oriented stuff, that kind of philosophy got lost a little bit.
Yes, the Enterprise OO.
Enterprise OO, the C# and Java and so on. The focus tends to be on classes and on much more structured way of doing things, interfaces and stuff. And I think that kind of got the original concept of OO sort of got lost in the shuffle there. Agent-based programming is obviously making a big comeback through, Akka and cloud-based stuff. And then having explicit dependencies, dependency injection, obviously, and making things easy to unit test. So definitely the philosophy of having a black box is sort of out of fashion right now.
Do you feel then, because obviously again encapsulation is a big part of OO, and do you feel then like the data being treated as an implementation detail inside of OO, and it's the fact that it is this black box, is a good thing? Or do you prefer, you know, as you say with like unit testing and stuff, I'm guessing it's better to have this exposed, as it's almost like it's, you know, something you're passing in and you're getting out and you're kind of managing it in your own way?
Yeah, I think transparency is one of the things you want in programming. I mean, ideally, you'd be able to look at the method or the function, and you'd be able to tell everything about it without having to look at the source code. You can say, well, it takes this input and it has this output. And if you're a functional programmer, you say, well, I know for a fact that it doesn't do any kind of I/O because it doesn't have an I/O type, and I know for a fact that it doesn't raise any errors because it doesn't have an error type. And if it does have an error type, I need to handle the errors. And if it does have I/O, I know it's going to be doing I/O, whatever. And you try to make everything explicit, and ideally you shouldn't have to look at the actual implementation to figure out what it does. I mean, I don't really care what the implementation does as long as the input and output is very obvious. So in order for me to use the function, I shouldn't really care how it's implemented. But with traditional OO, I can't really do that. I have to really look inside. So the theory was nice of having self-contained encapsulated objects, but in practice, it makes working with them quite painful sometimes.
That's it, yeah. As you say, like, I mean, in testing is probably one of the biggest ones where it's this whole setup process. The arrangement process just becomes such a trying and, very internal. Like the fact that we're trying to get away from the fact of knowing the internals, we have to know them enough to get the object into a state that we then want to be able to test.
Exactly.
And it kind of defeats it's almost like defeating the purpose of the fact that we want it to be hidden. We're actually making it harder on ourselves as opposed to exposing the fact that, yes, this is very simple. It's input, output, and that's it.
Yes, I think so. Exactly. And I just think the rise of unit testing, the rise of property-based testing, all these things lead to a certain style of writing code which is very, very transparent. And the classic object-oriented model is not transparent. And so I think that's one of the reasons why people are having problems with it. If you try and follow classic OO, it's not so easy.
And then so from that, we had the behavior and state, and it was mutable state, all in one area and one place. And it was just that black box. And then you went and discussed, splitting those out. And you said, okay, well, we had this abstract mutable data model. Yeah. And that's been around for years. And the idea was you had these simple functions and you'd have your mutable state still, but you'd pass that in. And as a side effect of that, function running, the state that you'd passed in had changed.
Right.
And then from that, then it kind of leads on really well is to the immutable way, which is kind of the way we think of functional now. And pure functions is that, you have your inputs and then you have your outputs. And the output, the inputs never get changed and you get a new output and it's all immutable. And I'm just wondering kind of, are there any advantages you can still see to using a mutable approach where, you have that really kind of side effecty, it's changed, but it doesn't really feel like it's changed because there's no return, it's void on it and things like that. Is there any performance gains from doing it? And would you still recommend it in certain areas?
Yeah, I mean, mutability is generally more performant than immutability. So, for example, if I have an array of 1,000 things or 10,000 things and I want to change them all, it's a lot faster to change them in place than to make a whole copy of the array and change each one. I mean, it's not as, I mean, that's generally the thing. I mean, it's not just changing in place, but I mean, if in high performance things with a managed thing, with managed code like C# or Java where there's garbage collection, allocations are the things you really want to avoid. If you can avoid allocating new objects, because that's the killer in terms of performance. So, mutating something in place avoids having to allocate new things, and so that's one of the reasons why it's faster. But in practice, for most people, I mean, if you've got a hotspot in your code, or you're doing high performance code anyway, then yes. But I think the classic thing is don't optimize prematurely. Write your code in the way that's easiest to understand for other programmers. If there are performance problems, then you can optimize it. But don't optimize it before you need to optimize it, because it turns out that if you write code, if you do use immutable things and you write very clean code can often be handled very nicely by the runtime. For example, if very short-lived objects, the allocation cost is very cheap because they die young. And so immutable objects that get allocated and then deallocated straight away are not as expensive as you might think they are. So, I wouldn't really worry. The benefits of immutability are generally so much higher because if it's immutable, you can, again, it's transparency. You know that this code is not doing anything weird behind the scenes. It's not changing anything that you don't know about. If it's changing something, it's giving you back a new object which has the changes in it. So it's a lot easier to reason about the code. And I mean, the classic thing is, why are you writing code for the computer or are you writing code for other developers? Mostly the reason we're using high-level languages in the first place is because we're really trying to communicate with other people. We're not really trying to communicate with the computer. The computer, is smart enough normally, if we have a decent language, to understand it without ambiguity. But it's most of the problems in code are really, certainly in the domains I work in, which is more like enterprise coding, most of the problems are not to do with performance. They're to do with understanding what the customer wants and understanding what other developers have done. You're looking at code that's a year old or 2 years old. It's like, I really just want to make sure that this code does what it says it's doing. And one of the things, if you're not sure what it does, you tend to be very risk averse about making changes. Refactoring an old code base is like, if I touch it, how many things are going to break? And that's the terrible feeling. So you end up with this horrible legacy code that nobody touches because they're too scared about breaking something. And if the code is much more transparent and things are immutable, you tend to have a lot more confidence about making changes. Feeling that you hopefully won't be breaking things, as easily if you can reason about the code from above that way.
Yeah, absolutely. And it's the brittleness of code. And I think the worst thing a code base can ever get into is a state where it says, no one's allowed to touch this. We really have no say or no, we're totally worried that if we tweak one thing on this, we don't know the side effects, and this is where mutability comes in. We don't know what else is going to change or break. Exactly. Some other feature, a completely other place could be broken and you have no idea why unless you look and rummage around. And as you say, like, it's the cognitive overhead as well, and it's reducing that, and the fact that immutability at the price of maybe a little bit of performance does give us that. And we would all be writing assembly then. If we really wanted the ultimate performance, we would be writing in the lowest possible form, right, as opposed to all these the higher level languages that have been brought up and made. Right. It's for the fact that we want to solve problems and communicate with us as humans as opposed to the computer.
Yeah, and like I said, it depends on which. If I'm doing device drivers or something, I'll be writing in C, or C++. And if I'm doing enterprise software, I want to use a high level language. I don't want to be messing around with pointers and stuff, and having to do my own allocations and stuff. So yeah, it obviously each system is different, and sometimes you get, I think, programmers, people who are used to systems programming, they complain that it's like you can't control the performance. It's just a different domain. It's a huge number of different kinds of problems, all solved by programmers, and they're very, very different problems. And I don't think we should try and have one size fits all.
And it's really interesting because one thing on my exploration of Clojure is the idea of like the transient data structures. So by default, everything's obviously immutable. But if you need that performance, you can use transient data structures that will essentially unlock the box and allow you to do like kind of the mutability. And it's got a really interesting, there's a really interesting quote on it. Like, if a tree falls in the woods, does it make a sound? And if a pure function mutates some local data in order to produce an immutable return value, is that okay? And I think it's that kind of working out where your boundaries are with mutability. If internally I have to do some mutable state just to get to a place that, as long as I'm returning an immutable value, that then to the client it's just a pure function. It's just to get to that actual result. I feel that's an okay way to be.
Oh, absolutely, and it's very common. I mean, in F# too. I mean, when you sort a list in F#, it basically copies it into an array, sorts the array in place, and then copies it back into a list. It turns out that's faster than doing all the allocations to sort a linked list in memory. That kind of thing. Yeah, as long as nobody sees it. No, I mean, the whole point is its transparency is what they call referential transparency, where I can replace the inputs and outputs. It's always going to give me the same input and the same output, and I don't really care how it works inside. Yeah.
But again, it's the cognitive mental overhead of not needing to worry what's happening inside. And it's just the fact that it's an implementation detail to make it a bit faster. Yeah. And as long as we are providing that immutable, return, that then the actual consumer can still work with it as they wish.
Yeah.
The next one, actually, and I'm going to bring up the M word there, so the state monad, and you bring it up in a really interesting way. Not only now you want to make the turtle move around, but you've also got this idea of collisions, or the idea that does it actually do the intended action that you want, and how much did it actually be able to move? And that's when you get this idea that a function, from one input to multiple output. Could you maybe explain what actually the state monad is, and what kind of, what is it trying to solve?
Right. Okay. So in the talk, I talk about the problem with having immutable stuff is that every time you do something, you get a new copy of the state back, because you can't change the state. You just get a new version of the state with the position and the direction and stuff updated. Now, if you have very simple operations, you can use in F# the piping operator just to take the output of one function and feed it to the input of the next function. So if the only thing that's being output from the function is the state, you can feed it directly into the next function, and that's fine. But if you start having more than one output, if you have the state plus some information that you need to work with, the code starts getting really ugly, because you have the state. When you're coding, you don't really care about the state of the turtle most of the time. You just want to focus on the business, on the logic, which, like, if it hits the wall, turn left. That's the logic. I don't really care what it is. So the state monad is a way to thread the state through your code logic, kind of behind the scenes, so that you don't have to deal with it explicitly. And if you use the state monad, your code can handle the state, and yet it doesn't look like it. It ends up looking almost like imperative code, like, call this function, if I've hit the wall, do this, and if I haven't hit the wall, do that. And the fact that the state's been threaded through the scenes, behind the scenes, is basically transparent. So how the state monad actually works, probably not going to go, I can't really explain it. And in fact, a lot of people don't really care how it works in practice. I mean, I do kind of quickly go into it in the talk, but the point is, it's just a concept that allows you to do that. And if you're interested, you can learn more details. I have that's my whole Frankenfunctor talk. Yes. It's all about building the state monad. So yeah, in Haskell and so on, you pretty much have to use the state monad to keep track of state. In languages with mutable things, it would be possible to not bother with that and use a mutable state. And depending on how I was feeling that day, I might actually do that. I might use a mutable state, and because as long as the mutable state doesn't escape from the scope. So if I'm doing something like drawing a triangle, I'm going this direction and turning and going that direction again and turning. And if I say a function to create a triangle, I could have the state be mutable within that, but then not expose it outside. And so I'm quite pragmatic. F# is quite a pragmatic language, and you can choose to use mutable state or not. The state monad is a bit ugly to use in F#. In Haskell, it's easy, it's better supported,
So really then, that the idea of the state monad is the fact that, we want these pure functions that are returning, maybe the state, the next state, but also it has a different shape, and we're not able to just puzzle these things together because they're all one input function, one output functions. And it's that idea of really it's hiding through, like what is the most important bit of this, within an abstraction, trying to just say what's the core domain problem that we're trying to solve. And it's just behind the scenes, then it's handling this extra layer, but it's because of the purity that we want to use that, as opposed to just using side effects and using immutable data structures.
Yeah, exactly. And then what the state monad allows you to do is write functions which have everything, where everything is immutable and there is no mutable state anywhere, but then use them as if you were working with mutable state. So use them in a way that you didn't have to worry about keeping track of state. But behind the scenes, each individual function is actually a pure function, and means you can test them individually. All the benefits of using immutable data and pure functions, you can test them on their own. You can compose them with other functions. They don't have any global variables that they need to access or anything. So they're still very composable. It's just really a trick to allow you to hide some of the management of all that stuff when you're working with in practice.
It's a win-win all around. And I was going to ask, actually, and I think you did touch on it a little bit, is kind of the balancing of the cost of introducing abstractions like this. When you employ such a thing as opposed to using mutable, and you say you're pragmatic, so I'm guessing it is just a kind of, you see how you feel and if the problem requires such a concept of abstraction to be used, as opposed to just using mutable data and things like that.
Yeah, I mean, the state There's a few other monads which are used. We'll talk about them. Using the success and failure, and then using async, where you sort of there's no way around that really, and they actually add a lot of value. The state monads, the value adds, I'm torn. I think it really depends on the scenario. But in F# I would say it's relatively uncommon to be using it, just because I think the cost, at some point the benefit is outweighed by the cost. So the benefit of hiding the state, is that really worth it? If you just have a mutable within your scope, you have 5 lines of code that reference a mutable, isn't that easier? Is it easy for someone else to understand? It depends. It depends on the team you're working with, and it depends on how much you care about being super pure all the time.
And that's it, yeah, because I suppose you've obviously got 2 camps, you've got more than 2 camps, but you've got like the idea of being completely pure all the time, being a pragmatist, and then being like obviously mutable, like it doesn't matter, anything goes. And I suppose you're in the middle camp there, that it depends on what the problem is, and it depends on how many source lines it is, because if you can read in a little block, okay, there is a bit of mutability going on here, but I can understand it, as opposed to trying to unravel this abstraction layer, the cost of it to make it easier to read, because I'm guessing the abstraction layer really for the state mode is to make it easier for you to read and understand the domain logic, but then adding the mutability in again is another layer where it's like, okay, well, it's actually easier for me just to expose that and be like, yes, we are breaking purity here, but in the case to make it easier for you to understand.
Yeah, I would always start erring on the side of purity. I mean, I think one of the things that functional programming has really helped contribute to the conversation about programming in general is changing the defaults. So rather than having mutability as the default, immutability is the default. And if you want mutability, you have to ask for it specially. And, the same thing with just many of the things are just slightly, the defaults are just different in a functional programming language. And I think that's good. So I like having the defaults be pure functions and immutability and so on. But I like having the escape hatch also. Personally, it's like when you need it, it's just nice to be able to. I'm not a purist in the sense that you can't you have to always be pure for the sake of it. I think the point of programming is to solve problems, and the point of writing code is to communicate that to other people, and other people also includes you in 6 months' time when you've forgotten what you did. So even if you're a solo programmer, you're still communicating with your future self, So. Yeah, so what is the best way to communicate stuff without getting you into trouble? Now, anything that causes, the caveat there is anything that's going to cause you pain, like having global variables that mutate, without, that's bad. Yeah, so don't do anything that's going to cause you pain, that's going to make it hard to debug, that's going to make it brittle or something. But like I say, having a little bit of mutable state for the next 5 lines of code and then wrapping that up inside a function, I'm okay with that.
That's cool. And then so following on from that, you kind of expand on the problem and you kind of say, well, let's handle these cases, of have we successfully been able to move to the distance we wanted, or add a failure case in. And, you've got all this idea of the try-catch, the if-else's and trying to handle it that way. And obviously in the OO world, the enterprise OO world, you'll be throwing exceptions out and all that horrible stuff. But you come across a very elegant, either monad and using the success and failure there. And it's very much like your railway-orientated programming. And it's explicitly handling those error conditions during the computation without using without using the exceptions. And I'm just wondering kind of what is the either monad?
The either monad, it's basically, I've got it as a result type, which is success or failure. In Haskell, the either monad has a left side and a right side, and by convention, they have the right side be the success side and the left side be the error side. Most other languages, the problem with F# also has a choice type, which is, again, has no bias towards either side. Most languages, Rust and OCaml and stuff, now have a result type, which is biased towards the success case. So when all the functions assume, they're about chaining successes together rather than chaining failures together. So I call it result, but in Haskell it would be called the either monad. The thing about talking about this, the reason I like it is that in the state monad, there's trade-offs between clarity of code versus how hard it is to use the thing. I think in this case the trade-offs are very high because error handling really contaminates your code, and it's really easy to lose the logic of what's going on when you have exceptions and you have, if you look at any piece of code, you'll probably find that most, like 30% of the code, maybe 50% of the code is actually error handling. And it makes the code ugly, but more importantly, you lose what the code is supposed to do, which is communicating the intent of why you wrote it in the first place. And so what I really like about the either monad or the railway-oriented programming, whatever you want to call it, is it hides the failures and focuses on the happy path without just ignoring the failures. Because, I mean, one way would be to just write your code and assume that nothing's going to go wrong, and that's equally bad. So to me, it's just a very nice middle ground between looking like everything's on the happy path but handling the failures nicely behind the scenes.
Being explicit, and I think that's the one thing about these error conditions, explicitly handling them as opposed to the exceptions where you just don't know. And I know that we spoke about it last podcast with you that, it's the idea of, well, it could just throw and I have no idea and it's not trusting that function and the function's not giving me kind of an idea of what's going to happen. At least in this case, I know the return type, it could fail or it could give me something back. And it's been able to say within the monad, this way of being able to construct them and handle them together is able to then just provide that core business problem. And kind of express that.
Yeah, I mean, the nice thing about you returning a result, it's very clear that this function could return an error. It's again, making the function much more transparent about what it does. And if you have an error type, rather than using a string, if you have an error type, which is a choice, a union type, you can see here's all the possible things that could go wrong with this function. So that's very nice. It's a much more self-documenting way of using the function. I should just point out, some people have said that using result type everywhere is a bad idea, and I agree. In some cases, I would reserve this for domain errors, things that might happen and which you need to document. Things that you can't handle, like out of memory or null reference exceptions or whatever. Those shouldn't be handled by either. But they throw. I mean, there's nothing you can do. So
it's exceptional behaviour, isn't it?
Yeah, those are like some languages call that panic. Basically, something went wrong. I literally can't handle it. That's a good case for using exceptions. You just throw the exception, and it gets caught higher up at your boundary or at the top level of the program, and gets logged and stuff. But so the kinds of things I'm talking about here, to be clear, are things which are part of the domain. These are things like hitting the wall in a turtle graph. That's something you would expect to have. I don't want to be throwing and catching exceptions for that. I want to return that as a failure that I can then actually have that as a documented kind of thing.
Thinking of it, as not only just success and failure, and thinking it more in like the either left or right. Have you seen any other kind of use cases for using a left and right, the railway oriented approach, other than just error handling?
No, because you can have a union type with two choices, with two possible, where something went this way or something went that way, and there's no bias towards either one. With the railway oriented model and the either approach is that there is a bias, that you're chaining successes together, and then when you get a failure, you're going to be bypassing the rest. So the result type, and that's one of the reasons why F# actually has both. It has a result type which is biased towards success, and then it has a choice type where there's no bias either way, and it's not clear at all. What the first choice and the second choice mean. It's up to the user to decide what they mean. So it's fair enough to have both. So I would use if it wasn't a success failure, I wouldn't use the result type. I'd use a different type. And it's very easy to write your own types. If I'm returning something which is, you're returning either this or you're returning this other thing, and neither one is right or wrong, then I'd probably write my own type, because it's so easy to write a quick type that documents that. So,
that's it, and being more expressive in the domain.
Exactly. I tend to err on the side of over documenting things, again, because I'm a fan of having my code be readable, and I don't like very short variable names. I don't like obscure types that are so abstract that they don't make sense.
Well, there's no need for I's and X's and Y's now. We have the ability to have as much memory as we want. We can be as expressive, to a limit within our variable names, our function names and stuff. And we're not trying to conserve memory. Yeah,
well, I mean, in code, the variable names obviously get compiled out anyway. So it's about communicating with the developers. The compiler doesn't care how long your variable names are, but developers do, or other people who are reading your code do. So, I mean, I don't mind. It depends. The classic argument in functional programming is if I have a function which is very generic, you can't give sensible names to those things.
X's and Y's.
So you tend to use X's and Y's because, composing two functions, they're typically in the parameters are called F and G. They're just two functions. You could call it function 1 and function 2, but that's not really giving you any more information then you had, or first function and second function. Yeah, I mean, it maybe for beginners, actually, calling it first function and second function might actually make it easier to understand. But so I don't mind using short things when the context is really obvious. Like if I've got a loop and I'm calling it I for the loop index or something, I think that's fair enough. It's so obvious. It's such an obvious thing to do. But in most of my code, I try and have quite long-winded names, which is, I think, hopefully one of the reasons why people, like my examples, because I try and make them easy enough to read. Just from the names. The other thing is, from a function program point of view, the name shouldn't be important, because from a mathematical point of view, what you call it makes no difference to what it does. You can call it X, you can call it Y, you can call it anything. It's the same function. It doesn't matter what you call it. So one of the arguments there is just call it. If you call it something obscure, then you're making it very obvious that it doesn't make any difference what you call it. You've got X's and Y's. Well, I actually disagree with that, because, again, the person the reader is more important than the compiler. So the names are a great way of communicating something. It's true that the compiler can't check. You could totally misname something and give it a very misleading name. But that's true, of anything. I think names are a very valuable resource. We spend a lot of time looking at code, and I think a good name is worth its weight in gold. So I try and do that in my code.
Well, it's like you say, with like the index as I and things like that, and it's all about proximity, isn't it? Like if, how far a distance is this going to be used? Because things that are going to be further distance, I shouldn't just call it I, because I can't get any context from just looking at it. Oh, this is within a loop fashion. It's, it depends, the longer the name typically is when a further proximity from when it was actually generated or, assigned.
Exactly. That's exactly right. Yeah. If I have a global variable called I, it could be anything. But if I have to find it 2 lines above my code, it's very clear. And that actually brings me to another little pet peeve about functional programmers, is some functional programmers really like to use weird symbols.
Yes, it's cool. It does look cool.
It does look cool, but you've no idea what they are. And you could say, well, you need to learn what they are. And it's true, some symbols are so common and they're so consistent between languages that it's fair enough that you have to learn what they are. I remember when I was first learning C, and I saw the plus, and I was thinking, what does plus mean? How is that different from a normal plus, So you just have to learn what it means. And in F# there's the pipe symbol, and there's composition symbol, and there's bind symbol, and so on. There's a couple of ones which are pretty standard. That's fair enough. But I think if you're writing a library to be used by other people, it's quite hard. This goes to this thing of trying to, having to look at the source to try and figure out what it is, because a symbol, it doesn't have a name. So what I have to do is go to the file and look at the comment associated with the symbol, or I have to find out what the symbol is an alias for. And so if I do use, sometimes a symbol or an operator can be really, really helpful, but I like to sort of define it at the top of my file so that people can find it really easily. So in the library, I would use, a word like map or something, and then when I use it in my code, I might define a symbol for it, but then it makes it's right at the top of the file, and it's easy to find. It's not buried in some import somewhere.
I think it's a great way, and like the fact that they've got this whole Unicode spectrum that people typically, find that they can use all these symbols, and just say, it can get quite bewildering in some libraries.
Yeah, I think again, I think there's a little bit of a schism between we talked about this last time about programming as maths versus programming as as a social activity, and if you're formatting an equation, it's quite nice to have the arrows look like real arrows and fancy symbols and stuff, but I don't think we're writing maths. I think we're writing, certainly the kind of code I write is not particularly mathematical. So I try and avoid using symbols if I can.
And then, so following on from that, then you then kind of bring up the idea that what happens if, I do this move, but I don't know, maybe it's just a robot, it's, on a network connection, there's some kind of, delay, and it's an asynchronous in nature. And it's how to handle those, and that's kind of dealt with by the asynchronous or async monad. I was wondering, actually, is async a monad? Like, is that a name for it, or does it have a more generic kind of naming?
Well, async is F# word for it. In Haskell, the nearest thing would probably be IO monad, which is monads are very tricky things to explain. It's more like a pattern than a thing. So it's a data type plus some functions plus some rules about how the functions have to work. So it's actually three sets of things, not just a data type. So when people talk about list monads and stuff, you have to be careful, about what it's not just, I would just call it a list, So in this case, async is really a way of programming where you have callbacks, So the classic async is you do something and you don't know how long it's going to take. It's gone off to do some outside world stuff, and when it's finished, it'll give you call back when it's done, and you pass it a function to call back. So you can totally write code that way in most languages, and in JavaScript, for example, you have what they call the pyramid of doom.
And you use promises and stuff to narrow that down.
Yeah, you have callbacks within callbacks within callbacks within callbacks, and your code starts getting crazy. So the async in F# and promises in JavaScript and various other things, it's about handling that complexity. And just like with the state monad, we pass the state behind the scenes, and with the either monad or the result monad, we pass the error handling, the failure case behind the scenes. In this case, we're handling the kind of callbacks behind the scenes. So when you write your code using async in F#, things are happening through callbacks, but your code. It doesn't look like it in your code. Your code looks very straightforward. Do this thing and then do this other thing, and the fact that the two things are connected by a callback is hidden from you, and again it makes the code much easier to read. So yeah, and in F#, the async is implemented in a monadic way. It's implemented the same way as all the other things. In languages like C#, it's implemented as part of the compiler, so you can't write your own version of it so easily.
That's cool. And so from this, we've just spoken about these three monads or, monadic structures. And it's really interesting looking at this. And then you realize the familiarities and kind of similarities between them. And it seems, as you say, you've just mentioned, kind of you're adding that level of complexity to hide a certain behavior that, is managed or threaded through without your needing to worry about it really. And, you're dealing with a certain problem. You're focusing your lens on just one bit of the problem. You're saying, okay, I want to hide that other bit. Similarly, how you would construct something in OO, or, you'd kind of, design a system in general, really. Would you say that this is like the key value of monads in general use cases, is that kind of abstraction to hide certain bits and then allowing you then to control and focus on one single bit?
Yeah, monads, the fundamental usage of a monad is to chain functions together. The kind of driving, the core design principle in functional programming is composition. So you want to glue smaller things together to make bigger things. And when you have, let's say, normal functions, gluing them together is very straightforward. Or functions where the output is the same as the input of the next function, you can just glue them together very easily. But when the output is different from the next function, when it's the wrong shape because it has something like I/O, it has async, it has errors or something, you can't just glue them together. So the monads is a technique for allowing you to compose certain kinds of functions together as if they were kind of simple functions. So that's really the main benefit of having monads, is they hide the complexity of gluing things together. They make it easier they allow you to focus on the composition and ignore some of the other things which get in the way of that.
On a bit of a tangent, actually, a kind of different thing. Why do you think people find it so hard to kind of grasp monads? And there's always this thing of like a monad is a burrito and all these kind of weird analogies for them and stuff. And it's very one of those things where I think a lot of people want to know it. And do they even need to know it, I suppose, is one thing. At its core, or is it just, understanding, at least I understand that, these kind of techniques like the success and failure, the async, and understanding, that I can use this thing called a state monad, or, this kind of abstraction?
Yeah, I think a lot of people explain monads by saying, here's the definition of a monad. And the problem is that's completely irrelevant as a programmer. You don't care. Really, and
the laws.
If you're doing, it's like, do you really care? How does that help you get your job done? What you really care about is error handling, or async, or whatever. There's certain practical problems that you're trying to solve. And like I say, you have these different kinds of functions which have outputs which are not composable straight away. And then there's like, if you write these kinds of functions, you write some helper functions like map and bind, it turns out you can glue them together, and that's awesome. And then once you've done that 3 or 4 times, there's a pattern there. And at that point, you can say, okay, at that point you might introduce it and say, well, okay, a monad is the abstraction of that pattern in general. But I really think, to be honest, people do not need to know about it. Certainly they don't need to know about it to get started. I mean, that's one of my issues with Haskell is that, you have to know about monads before you can do Hello World. And I mean, I understand why they do that, but it's unfortunate that people
barrier to entry just
it's just a
too
bit
high.
of it is. And I personally think that you should just be able to dive in and start with practical things, and then once you've got experience, then you can start seeing patterns between various things. But you can't see the patterns between things if you don't know the fundamentals of the things themselves. If you haven't done the error handling and you haven't done async and you haven't done the stuff, that you're not going to see having a monad is not going to make any sense to you, because you see no point. There's no reason for it, So I think you have to start from the concrete, and once you've got the examples, then you can start seeing an abstraction across all those examples. So it is useful I think it is a useful concept, but I don't think it's a concept that you need to know to start programming.
Well, I say for the audience, I definitely recommend your Dr. Frankenfunctor, and the Monad stuff. That's another silly talk. But yeah, that's really it's a great talk.
Oh, I'm glad you like it. Just for the audience, that's when I basically take the Frankenstein thing, building a monster from the parts, and each part has a different problem, and you have to glue them all together. And that was, again, when I came up with the idea of that, because I really wanted to focus on composition. How do you glue things together? And so I had the idea of assembling a kind of Frankenstein monster.
It's a really great idea, and I think that's one thing, again, like the thread throughout all the way your analogies you use and stuff. I think they're great, and they really kind of allow, specifically me, to kind of relate to and understand at least this, quite complex topics.
Yeah, I mean, I think you've got to have a bit of fun, and they are kind of complex topics, and I know some people think I'm trivializing things, or I'm making things too silly, and I'm not really going into the kind of theoretical detail behind these things. And to which I say, well, so what? It's like, if you like theory, there's lots and lots of academic books that will explain all this stuff without using silly analogies. But if you find all the academic stuff quite hard, then hopefully my stuff is a bit easier to digest. So.
Well, no, absolutely, and it's how it unlocks it for a wider variety of people. Say a lot of people aren't going to want to pick up and understand or try and at least these very abstract terms and stuff, and they're going to need examples, and they're going to need examples that are going to work in their day-to-day life, or maybe in this kind of made-up world you've kind of devised in the Frankenstein kind of model, and it allows you to really see like the play-by-play of what happens. And I think that's what as programmers we kind of like, is that kind of idea of here's the problem we're trying to solve. And these are the tools we're going to use to solve it.
Yeah, exactly. Practical problem solving. I think most developers relate to that.
Absolutely. And actually, really on a bit of a tangent, actually, with one, and it was mentioned in that presentation, and the fact that list is a monad, or has a monadic structure, and the idea of map and flat map, or in this, bind. And I think for me, actually, one of the hard graphs, I think a lot, what you see when you go into functional programming, or really general now, kind of the general move away is to like this idea of list comprehensions. And actually, you mentioned, in Smalltalk that it already exists. The idea of like mapping, and then you had the flat map, and kind of taking away the fact that a map isn't what we, I think a lot more developers probably now think of a map as being mapping a list to a function, but really generalizing that and realizing, okay, actually no, it just follows the same structures as all these other things like async and state and all that, and how they can be applied. Yeah,
I mean, again, the reason why people call list a monad is because if you have things that return lists, you can't really connect them to something that doesn't have a list as input. again, I'm not sure how helpful it is to the average person to say, oh, it's a monad. I don't really, it's one of the kind of, if you already know what monads are, then yes, that's interesting. But if you don't already know what monads are, that's completely useless. So I really avoid saying things like that in my blog. I don't think I've ever said that list is a monad in my talk, actually. I mean, I say it in passing, but I wouldn't try and stress it as something important.
And it's just those patterns, isn't it? And I think it's realizing the patterns. And I think as developers, we're good with that as well. We want to understand a pattern and see what's going on.
Yeah, patterns, exactly. I think developers think in terms of patterns. We tend to like to always, if there's two or three things where there's something in common, we do like to tend to abstract that out. I mean, that's definitely a kind of habit of programmers. It's a question of how much abstraction is, the bang for the buck. Sometimes you can have too much abstraction where people can't understand it. So, but I think it's definitely a habit of programmers to try and see patterns and things and try and, don't repeat yourself and make things more abstract if you can. It's interesting though. There's a bit of a counter movement in developers. I mean, the problem with abstraction is that and even in the OO world, you have very abstract. You have a factory that has a dependency container which returns another factory, which is you can end up getting something so complicated that you can't really understand it. And sometimes it's just nice to be concrete and to have just like the codes right in front of you. And I think
you don't want an abstract factory builder.
Exactly. And I think one of the reasons why people like languages like Go, because Go doesn't have generics and it doesn't have this and it doesn't have this, it's like very limited. The side effect of being limited like that is you can't do weird things. And it means that all the code is going to be very concrete and very in your face. And I think for many situations, that's actually exactly what you want. Too much abstraction can be just as bad as too little abstraction, I think. And so there's a balance there. But I can see why some people are sort of resisting languages where you can do some incredibly complex things. Someone posted some Scala code, which that was very, very hard to understand. So, if you have the power to do really complex things, somebody somewhere is going to do that. And in enterprise coding, I mean, that's fine in certain libraries or something. Sometimes you might need to do that. But I think in my context, which is, enterprise programming, I do think that you should write code. You shouldn't be able to write code that's too weird. And it actually, in a language that doesn't allow you to do that, is actually a good language. A language that doesn't let you do too much abstraction can actually be a good language to have, because it means that everyone's at the same level. You don't have this very wide range between the super weird stuff and the basic stuff.
Using a language that does really structure you to not allow you to kind of explore these other, these very abstract things, or it, kind of use these funky things. It allows everyone to be at a certain level, and there is none of that kind of a bit of random code can get into the code base that and again talking about like enterprise and thinking in that kind of world, someone else is going to have to pick this up, whether it be you in a couple of months time or someone else completely down the line. And it's that kind of code should be simple and boring.
Exactly.
That's the real kind of, that's the beauty of good code, is the fact that I can read it and it's pretty boring and I understand how it goes. And I know as developers, and I know me personally, I love a haha, or I love a little cool trick and be like, oh, look how cool this is. I'm like, well, I can't put that in source code and, commit it, because how much, me like 5 minutes ago didn't understand that. It's only because now I've grasped, I can use this cool trick, but it isn't something that should be used, for the general mass of code.
Absolutely. Yeah. I mean, I totally agree. Boring code is better in most cases. I mean, if you're writing a fun project for yourself, that's fine. But if you're writing a project that's going to have other developers looking at it and needs to be maintained, then yeah, boring is definitely the right way to go.
Yeah, and it's interesting because I'm primarily PHP. People want to add new things into a language, and it's very interesting kind of language design. People from all kinds of ilks, they're studying functional, they're from down to C people and all this, and people want all these different things, and it's trying to work out, well, what's the general consensus, and do we want cool stuff in the language? Would it make it harder for a beginner to pick up, or for someone who's just going to use this code? Is it worthwhile actually adding something in that a developer could take and really exploit?
That's a very tough question. I mean, I have a lot of admiration for good language designers, because it's very easy to go overboard. In my experience, the people who are good language designers tend to be very resistant to adding new features because once it's in there, you have to support it forever. And if you've made a mistake, you have to live with that mistake forever.
Which PHP has a lot of.
PHP is a good example of what happens if the language evolves without a clear plan. But, on the other hand, PHP is very successful. You can't argue with its success. But, I mean, as it gets more mature, you want to try and fix your kind of youthful mistakes. But unfortunately, with the language, you can't do that. You have to sort of live with that forever now, which is painful. But so, yeah, I'd be very resistant about adding new things. But on the other hand, yeah, people always want the latest things. And people want to emulate whatever the trendy thing is.
That is the thing, isn't it? And it's familiar in their language that they can use because their stack is X and they want to be able to do it in that, as opposed to going into a whole new stack saying, well, let's just use a Haskell or Erlang. No, it's that they want to bring those concepts they've learned or they've explored into a language that they already know.
Right. And the problem with that is you end up with object-oriented COBOL.
Yeah.
And, I mean, much as I like functional programming, I think that languages should have an opinion. And if they're not a functional language, they shouldn't start being a functional language because you end up with kind of half-baked pieces of, but you get some of the benefits, but you don't really get all the benefits unless you have a language designed around a certain paradigm. So funny enough, even though I like functional programming, I would be resistant to adding functional features to non-functional languages.
So that's interesting then. So, because what do you think of C# and Javas who are really going down that route of adding Lambdas and? I
think Lambdas are good because there's basically an inline anonymous function. That I have no problem with that. I would have C#. I think it's verging on getting too many features, too many language changes. They're adding pattern matching and they're adding case classes and they're adding various things. And I understand why they're doing it. But I don't know. I mean, people are demanding. It's a tough one. I don't really want to second guess what other people are doing. But I mean, for me as a developer, I would rather switch language. If I want to do a certain kind of thing, I would switch to a language that does it really well. And ironically, I mean, the thing with platforms like the JVM and .NET is the whole point is you should be able to switch between languages. If I want an object-oriented language, I want a functional language, and I can sort of mix and match them on the same platform, rather than having one language that tries to be a kitchen sink. So, yeah, it's a tough one. I'm glad I'm not a language designer because you're getting heat. No matter what you do, you're going to get flack from both sides. So.
Well, it's a really interesting point there because you mentioned the JVM and you mentioned CLR and stuff, and really kind of JavaScript is a very interesting case where it has become almost its own JVM and its own CLR because it's a platform for a lot of compilers and other languages on top of it.
Yes.
And I was wondering, what's your opinion on that? The fact that you've got JavaScript, but you've also got this extra layer on top.
Yeah, I think the ASM.js and WebAssembly and stuff like that, very interesting because, it's basically, you've got a language, it's been delivered to every platform already. Piggyback, but the language itself it's got some horrible nastinesses to it, even worse than PHP. But I mean, and everyone knows that. But so having a transpiling other languages to JavaScript is to me is a great solution because you get the benefit of using your nice statically typed language, and then you generate some very minimalistic JavaScript, which then the JavaScript engine knows how to compile I'm actually amazed how good the JavaScript engines are, given they're working with the language that they are working with. So I think that's actually a fine way of doing things. I can see a lot of future in that.
Yeah, it's almost become the fact that they have to, don't they? Because of the fact that it's the language of choice, that everything runs JavaScript now. It's the one way forward to be able to kind of expand and stuff is to be able to do this translation process. And everyone's got their own ideas. It's one of those things where, maybe I'm writing PHP, you're writing, F#, but we both need to run and use JavaScript. And it's whether, what type of, do you need a functional language? Do you like a Lisp? Do you want these type of things?
But there's a good example. I mean, if I have two different pages, I can write some of the JavaScript in PHP and generate JavaScript, and I could write some of it in F# and generate JavaScript. So it is the kind of common denominator, and it actually does allow interop in languages. Most of the transpilers allow you to use existing JavaScript libraries the F-sharp Fable one and, Elm and stuff like that, which is great because then you can piggyback on what other people have done, but then you still get to work in your own favorite language. I think it's great.
And that's the beauty of the JVM and the CLR, isn't it? The fact you can do that too. JVM, it's like I can take all these Java libraries that have already been made and use them in like Scala or Clojure.
Yeah. I think. Obviously, it's a little bit of an impedance mismatch when you're switching between, the libraries designed around object-oriented stuff with mutability, and you have to work in a functional language with immutability. But you just write a wrapper or something. It's not that hard. It means it's certainly faster to write a wrapper than it is to write it from scratch.
Hey all, so it turned out I actually spoke to Scott for quite a while in this episode, so I decided actually to make it easier, I would actually split this up into 2 separate chunks, so I thought this would maybe be a good logical place to stop. So yeah, I hope you enjoyed the show, and we'll speak to you again next week. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.